Let's look at a demo of how we can refactor this code to eliminate the static cling, or the use of static methods and properties, and also to add in some tests. And we'll look at some real quick unit tests and integration tests. The easiest thing to do with a tightly coupled legacy application that doesn't have a lot of abstractions is to start out by adding some integration tests. So we'll look at our integration test project where I've got a tests class, and the first thing we're going to want to do is verify that, let's say, extraction loads up the correct values for the things that it's doing. So extract, we can see that it's trying to get invoices after a certain date, and then it's trying to get the employees also from that Northwind table. So in this case, we can say something like extract should load invoices, and let's just say that should is our name, and then we can put in a public void load invoices, and we'll call this a test, so it will run. And now we can go and try and test our code. So let's rename our class here, rename the file, and of course there's no easy way to test our code at the moment because all the logic is inside the program is marked as internal, and so it's very difficult to get to this code. So the first thing that we need to do is try and extract out the extract method into something that we can work with. And so to start with that, we'll create a new class, and we'll call this class extraction service, and we'll simply move this entire block of code into that service, and we'll keep it all as a static method. And now here we just call extraction service.extract. Now the problem is that our extraction service needs to actually pass back some of this data. This employee table needs to come back, this invoice table needs to come back. So instead of having a void, we're going to create a new result. We'll call it extraction result. And it has a public data table, invoice table, and a public data table, employee table. There's a number of different ways that we could do this, but this one will work. And then in our method, we'll say that we need a var result equals new extraction result. And then we'll set this to be result.invoice table. Replace that everywhere. Similarly, the employee table will be result.employee table. Replace that everywhere. And then instead of void, we need to return an extraction result, which means that down here at the end, we return result. And here in our code, we will also say var result is equal to this. Make that public. Good. And then we need those to be on our local values. So we'll say that employee table equals result and invoice table equals result invoice table. Now we hope that that still works, so we'll try and build. We'll try and run. Code still runs with our manual test. So now we can go into our class here and we can do the same thing. We can say var result equals, let's make sure we've got our namespace, extraction service dot, there we go, get our namespace, dot extract. Now you can imagine that I'm going to be talking to a different database. So let's go ahead and we'll run this test right now and we'll watch it fail. So Let's go and run our unit test. And it's failing right now because it could not load the assembly. Or one of its dependencies, right? Now at this point we can actually run our test, and it should work because we're using hard-coded connection strings within our program. So when we talk to this database here, it's going to be talking to the same database that our live application talks to. Now obviously we've got another to-do item to pull this out into some kind of a configuration value, and then within our integration test we would change that out to talk to a test database. But for now let's go ahead and run this unit test. And here you can see that we got our output. The other thing that we can then do to make our test actually valuable is we can start asserting something about the results. So we can say assert.requel result.employeeTable.count, or rather .rows.count. And for now we're just actually trying to put our system under test so that we know that it does what it does. So we expect it to be some number, and we're going to verify whatever that number is here in just a moment. So we'll change this to be invoice table. We know it's not 0. We're going to set it to what it really is. So 2155 is the number that it got back for invoices here. We'll set that. And we'll run it again. And we got 9 employees. So we'll set that here. And we've got a successful test. So this is our first integration test now that we can run. And this basically verifies very little. It proves that we're getting back the number of rows that we expect. And it's the reason why we expect them is because it's the amount of rows we get back currently. This is called a fixing test because it fixes what our application does and what we expect it to do at this point in time. And it lets us continue to make changes now, confident in the knowledge that when we run this test, it'll verify that the behavior that the system currently does has not been changed. These are nice to have when you're going in and doing a large refactoring, because the purpose of a refactoring is to change how your code is designed and how it interoperates, but not to change its behavior. So you'd expect that whatever it was doing previously, it's still doing. And so these are valuable from that point of view. However, they are very slow tests. If we look at the time that this test took, let's run it one more time. And we can turn on timings here. You can see that this test took about a second to run. Now that doesn't sound like that's too bad, but as we continue to add tests to this, we're going to have hundreds of tests. And if our code takes hundreds of seconds to run, it's going to get very, very slow to run these every time we want to do a check-in or every time we want to verify that our code still does what we expect.